Aloha! Welcome to another episode of The Curvature Amateur. I'm your host, Louis Montaigne, and today I'm going to prove you once more how the Earth is not a globe, according to the mathematics. And with this video, I'm not going to show you so well how the Earth is not flat. But anyway, let's beat the globe. All right, so here in Hawaii, which I believe should be the capital of the world of the curvature because of our tall island, like this one I live on, the big island of Hawaii, and also the other neighbor islands, which are tall, and the ocean level surrounding us. We can make some accurate measurements, as you've seen in my other videos. And so let's take an observation of Hana again, because looking at Hana is how I saw the curvature for the first time. And this time, instead of observing it from the Kohala coast, I'm going to be observing it from the Waipio lookout by Waipio Valley, on top of Waipio Valley. So let's take a closer look at Hana, see what it looks like in perspective. Okay, it's going 3D and let's close in on it. There's Hana. Okay, let's close in closer. So we can see our pu'u in Hana. A pu'u is a small hill. It's basically a crater remnant. So you can see this little mountain sticking up, this pu'u, sticking up like a sore thumb over the surrounding landscape. This is the town of Hana, okay? And you can see the nice waves splashing on it, as if the waves would splash that way up high, but that's just Google Map. And you can see a bit of land here that's very flat behind it, okay? And let's go, let's check out the elevation finder map. See what we're observing here. Our elevation. Closer, closer. Here's Hana again. It's only in 2D, but what I want to do is check the elevation of the pu'u. Here's Hana Town, and here's our pu'u. And here is Red Sands Beach. So if you don't want to be wearing clothes, there's your place to go, to be laying on the beach. So it looks like the tallest part is over here. What is the elevation? It says 344 feet. Makes sense. I've seen that before. About here, it's too low. 193. No, that's too low. 344. All right, let's go with that. It's a good enough number for me. And you can see a little island down here. Was that measure? 13 feet. What about that part of ground behind? What is going to be behind in our shot that we're going to be observing? It says 23 feet. Okay, about up here. 32. Okay, not so high. 36. Okay. 39. So we're about under 40 feet in this area, and 344 feet over here. Okay, now let's look at the elevation from where I was observing at the parking lot of the Waipio lookout. Across the ocean here, across the Alenui Haha channel. Let's get down to the Waipio lookout. This is Waipio Valley down there, my home. And here's the lookout. The Waipio Valley is down to the ocean level pretty much. And there's a steep road driving in and out of it, only one road. And there's a lot of elevation around this area. Like this area is lower than the parking lot. But let's look at the parking lot where I was more precisely. It's right here. Yeah. This parking spot. 928 feet. That makes sense to me. Another sample. Same thing. And you can see that down there is a bit lower. Is it? Yeah, 764. Wow, is that much of a difference? Anyway, so we got 928 feet. Okay. Now, how to calculate the Earth curvature. There are many websites on the internet. If you type in Google, how to calculate Earth curvature, or whatever question that would relate to the Earth curvature. And my favorite website is this one here from Math Central. Okay, if you go from one website to the next, you'll find out with your own experience, if you want to do that, that it's all the same formula. Okay, and this formula has been on the internet for years, at least 5 years, that the flat earthers have been poking at this formula. And I don't know how intelligent artificial intelligence really is. That's supposed to be governing every bits and pieces of data that we put on the internet, but they haven't gotten it right yet. They haven't corrected it. After so many times that I've been using this website and other people have been poking at this formula, somehow somebody didn't get the memo that we are challenging it. Okay, so why do I like this website of Math Central? Is because it has a nice little drawing here, and it's always very helpful in mathematics to understand what we're looking at. Thanks to Robert here. Robert who? Robert was asked by who? Other people at all levels. Okay, how can I find the curvature per mile of the Earth's surface? What is it? So Robert started off with this number here, 3,963 miles, okay, which is supposed to be the radius of our sphere Earth, if we're on a globe, okay? And you can notice how this number is precise here. It's not rounded off at 4,000 miles or 3,900 miles. It has accuracy. It doesn't have any digital, any point something behind it. Sorry, I have a little blank here. Decimals. Yeah, it doesn't have any decimals behind it. It's a flat out natural number. Okay? So he used this number here. He started off with that. And he only started off with 1 mile. Okay, how much in 1 mile? And he used the Pythagoras triangle, a squared plus b squared equals c squared. You can try the math if you want, all you want. And you ended up with this answer, 7.98 inches in 1 mile. And it's approximately 8 inches in 1 mile. Okay, so let's pull out our calculator and see what that means. Okay, Everybody knows the value of 2/3. 2 divided by 3 equals 0.666666 periodical. Nothing to do with the devil, but that's mathematics. And 8 inches into a foot, 8 divided by 12 is the same value. It's 2/3. Okay? Now let's take a look at 7.98 inches in a foot. What does that mean? 0.665. So we'll stick to this number here to have a little bit more precision than 0.666666 periodical. Okay? And the formula actually is you got to square the miles of distance that you measure. So the distance that you observe in length, you got to square those miles to be able to fit into this formula to see how many feet of elevation should we lose in that distance according to the theory that Robert pulled out of his Robert and other scientists that are all in the same boat. Okay, remember that. So, remember our elevation of the Waipio lookout, 928 feet, and elevation of the Pu'u in Hana was 344 feet. Okay, so let's take a look at our clip. I'm standing in the parking lot of the Waipio lookout. Sorry, I didn't bring my I have my altimeter, my own personal altimeter. It says 947 feet. And remember on the website we had 928, so we're close enough because this instrument measures the altitude out of thin air, probably according to the air pressure. And you can see I'm standing in the parking lot, and I apologize, I didn't bring my tripod, so I'm going to be a little bit shaky as we make this observation. I'm going to pause it to show you what we're looking at. So here's the island of Maui, and down here we have the Pu'u that is by Hana. It's not the clearest day, but that's the occasion I had to film it. So let's take a look at what we see here. Do you notice this Pu'u here? It's a little bit blur. Okay, but you can see the summit at 344 feet. You can even add the height of the trees up there, another 100 feet if you like. But we can still see the whole thing. And we can see the ground on the back side of it, which was under 40 feet, if you remember. And I didn't look at my elevation finder, but this here is like 90-some feet. Let's just go back to it to add a bit of accuracy to my research here. I call it avant-garde research. Some people might call it conspiracy theory, but most people that are accused of being conspiracy theorists are actually avant-garde researchers because they make a research no matter what they are being told by the authorities. So let's go look at the grounds next to the Pu'u, the low grounds next to the Pu'u. Okay, right in the middle of the baseball diamond here, 95 feet. Okay, another little sample. How tall are the grounds around there? 98 feet. We're still under 100 feet. Oh, 121 here. Okay, that's considerable. All right, around 129, we could say. Okay, let's go back to my video. Let's make it move so we see a little bit better. Sorry, wobbling. I had to lean against the guardrail, get some stability, especially after extending the zoom of my Nikon P900. You can see the hill, sorry, down in the ocean. Taking my time, doing my best to hold my breath, not to let the pulse of my heartbeat disturb the video too much. But yeah, you can see the whole height. You can see the ground around there. Remember, like under 30 feet of elevation in that area. That's on the other side of the pu'u. You can see a bit clearer now. You can see our ground 100 and some feet, 129 feet. And the height of the pool, 344 feet. We don't see the waves splashing so well along the coastline. So we're probably missing some feet. I don't know how many feet we're missing of the shoreline. I can't really prove that there is curvature in this video, but I have many other videos that do so. And as I was driving up the hill out of Waipio, you can't see that until you're high enough in elevation to be able to see this appear. Okay? And even for a while, the level of the horizon is higher as I was going up. It made it look like an island. But sorry, I can't really stop on that road to film when I'm driving my truck on this steep road. Gotta really pay attention where I'm going. And my elevation is 944 feet. Right, let's make a little measurement here. Forgot to do that. A little bit early this morning. Let's get out of 2D and back it out. We're going to measure the distance of observation from Hana to the Waipio lookout over here. And we get 51 miles and a half. Okay, so let's pull out the calculator. You can put some accuracy in there if you want. 51.56 miles. And we got to square that number. We got to multiply it by itself. Therefore, we get 2,658. Okay, and then we multiply that by 0.665, which is 7.98 inches to the foot, according to Robert's map. So we shouldn't be able to see anything below 1,767 feet if my eyeball was at the ocean level. Okay? But we can kind of see the ocean level in Hana. Like we're just a bit higher than the ocean level. Because we don't see any wave splash. Maybe it was calm enough that morning. But we still have a lot of numbers missing. Remember, we can subtract 944 feet, if you want, of where I was standing. We still have 823 feet that's missing somehow. And we can see the whole height of the pu'u, pretty much the whole thing. Like I say, we're not clearly seeing the shoreline. It's kind of hard to say that we have curvature in this video, but we definitely not have a globe. Once more, I'm proving that. I don't know how many videos I've got so far, but it's all about that pretty much, that we are not on a globe. Okay, how clear is that? Let's do it again. 51.56 miles. We're squaring that number. We get this number, 2658. We multiply that by 0.665. See, it's a big number, big number. That's way off, according to Robert's math. You know, And all the other scientists that claim they know these people. So you should put all your faith and knowledge into their hands because they know and you don't. But all you have to do is go out there and make some observations. If you get good big span of water and you get something tall enough on the other side, you can make some pretty good observation and trump the science. There's Waipio. Waipio, look out. It says it right here. Believe it or not. Until next time, aloha.